Assalamualaikum warahmatullahi wabarakatuh and greetings to all passing students. So we meet again in the second lecture of the pre-recorded video lecture. Okay, and actually this is the last part for the alkenes because for the lecture 4 we are going to learn about the alkenes. Alright, so in this lecture, actually we have only two learning outcomes that we want to achieve. Alright, so the first learning outcomes is to explain the halogenation reaction of the alkenes. So in these learning outcomes, you need to know how to write the reaction equation. Okay, and also you need to know how to predict the product from the halogenation reaction of the alkene. Okay, and the second LO is to explain the free radical substitution, mono, mechanism for methane, ethane, and propane. So this one we go deeper, we go more detail about the reaction itself. Okay, because we need to know the mechanism. How does the mechanism is going on to form the product, which is the haloalkane. All right, and as for methane, I have shown to you in the lecture notes. Okay, for ethane we want to discuss in this lecture, and for the propane is your self exercise in the tutorial, so that you will discuss with your respective tutor in the tutorial class later on. All right, so let's go for the question number 1 to achieve the LO number 8. All right, so the question is draw and name all the structural formulas or structural isomers formed by monochlorination of ethane propane, 2,2-dimethyl propane, cyclopropane, methyl cyclopropane, and 1,1-dimethyl cyclopropane. All right, so we discuss about the first compound. Okay, this is the structure of the ethane, the expanded structure of the ethane. All right, as you can see in this structure, there are 6 hydrogen atoms surrounded in the carbon atom. Okay, the 2 carbon atom, and all of these hydrogen atoms have the same surrounding, same environment. Okay, therefore, if you want to write the equation for this compound, so you write CH3, okay, CH3, and then chlorination is react with Cl2, and we need to put heat or the UV light. All right, heat or UV light, and then produce the product. Okay, what is the product? So what is the product? So actually the halogenation of the alkane is replacing the hydrogen atom with the halogen. Okay, and since in your syllabus you just learned about the mono halogenation, in this case is monochlorination, you want to replace the hydrogen with the chlorine atom, and mono means you just replace one of the hydrogen, okay, not more than one. All right, so let's say you replace this hydrogen atom, so you will produce CH3, CH2, Cl. Okay, and this haloalkane is 1-chloro ethane. Okay, next compound, propane. Okay, you can see that propane has 8 hydrogen atoms, but there are 2 different environments of the hydrogen atom. We have the primary hydrogen atom, and also we have the secondary hydrogen atom. Okay, therefore there are 2 possible product, 2 possible haloalkane product can be formed from this compound. Okay, so the first one is CH3, CH2, CH2, Cl. Okay, we replace one of the hydrogen over here with Cl. Okay, so this is 1-chloropropene. Okay, and if you replace this hydrogen with Cl, okay, this hydrogen remain, so you will get CH3, CH2, no, CH3. So one of the H is replaced by Cl. So this is the product, and the name of this product is 2-chloropropene. Okay, next, compound number 3, 2,2-dimethylpropene. We have 12 hydrogen atoms in this structure, but all of these hydrogen atoms are the same environment. Therefore, the haloalkane product is just a single haloalkane product. Alright, okay, satu sahaja haloalkane product, which is the H3C, CCH3, CH3, CH2, Cl. Okay, we replace one of the hydrogen, okay, and we put the chlorine atom, and the name of this compound is 1-chloro 2,2-dimethyl propene. Okay, next. Okay, cyclopropene. Okay, we can't see any hydrogen presence in this structure, but it's actually there are 6 hydrogen atoms because cycloalkane, the general formula is CnH2n. Okay, since we have 3 carbon, so hydrogen is 3 times 2, which is 6. Okay, where are the 6 hydrogen? It is actually over here. H, 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 H. Alright, so all of these 6 hydrogen atoms are the same environment. Therefore, you have a single haloalkane product, which is this structure. Okay, and the name of this structure is chlorocyclopropene. Okay, you don't need to put 1-chlorocyclopropene because it is already known this chlorine atom, you put in any position of the carbon is still assigned as the carbon number 1, right? Okay, next, methyl cyclopropene. Okay, so how many hydrogen atom in this molecule? Okay, so we expand over here, we have 2 hydrogen atom. Over here, we have another 2 hydrogen atom. And these 4 hydrogen atom are the same environment, which is they are secondary hydrogen atom. Okay, secondary hydrogen atom. We also have 1 hydrogen atom over here. This is the tertiary hydrogen atom. And also we have another 3 hydrogen atom at the methyl group. Okay, so this is the primary hydrogen atom. Alright, so when you replace the primary hydrogen atom, this is the product form. Alright, when you replace the tertiary hydrogen atom, you will get this. Okay, and when you replace the secondary hydrogen atom, you will get this. Alright, Okay, let's go for the blue color. This is the easiest to name the compound. Okay, at the carbon number 1 you have chloro. At the carbon number 1 also you have the methyl. Okay, so chloro is C, comes before M for methyl, so that the chloro is in at the front of the name of this compound. Okay, so 1 chloro, 1 methyl, cyclopropane. Okay, how about the red one? Okay, so you need to assign where are the first carbon. Okay, since chloro is located in front of the methyl group, so you need to give the smaller number for the chlorine. Okay, you give the smaller number for the chlorine, so that you start counting the number is from here 1, 2 for the metal, and 3 for the nothing lah. Okay, no substituent. Okay, and the name is almost the same with this one. Okay, the blue colored compound. Okay, but the difference is the position of the metal is at the carbon number 2. So the name will be 1 chloro 2. Okay, 1 chloro 2 metal cyclopropane. Okay, that one is for the red color. Okay, just change 1 to 2. Okay, ini untuk red color. Yang biru ni untuk the blue color. Okay, how about the green? Okay, this one is quite interesting. Okay, because cyclopropane is the parent. Alright, and we have the metal group. Okay, the metal group attached to the cyclopropane. But at the same time, we have the chloro attached to the metal group. We can say that the chloro is the substituent of the metal group, but the metal group itself is the substituent to the cyclopropane. Therefore, the chloro is the substituent over the substituent. So when you have the substituent over the substituent, you need to put the name of that substituent in the bracket. Alright, for example, for this compound, you can write as chloromethyl, CHLOROMETHYL, chloromethyl. But since this is the substituent of a substituent, okay, to avoid the confusing, we need to put in the bracket, then continue with the cyclopropane at the end. Okay, so that is the name. Okay, next. Alright, here we have only 2 different environment of the hydrogen atom. There are 4 secondary hydrogen atom. Okay, and also we have 3, no, not 3, it's actually 6 for the primary hydrogen atom. So we have 2 possible product. Okay, which is the green one is like this. Okay, and the red one is like this. Alright, so let's give the name for the green colored. Okay. Okay, this one we have discussed just now. This is the chloromethyl, CHLOROMETHYL. Okay, in the bracket, and the other part is the metal. Alright, so C comes before M, therefore the name for this compound is 1 chloro metal. Okay, tutup bracket, sambung lagi 1 metal cyclopropane. Panjang sangat sampai tak muat tempat. Propane. Alright, tapi sepatutnya kena sambung lah. Kena sambung. Okay. How about the red color? Okay, this one macam hampir sama dengan yang kita bincang in the previous compound. Tapi menariknya dekat sini, the numbering is different. Okay, kalau tadi we start the first carbon from the chlorine, from the carbon that attached to the chlorine atom, but this time you need to assign the first carbon that attached to metal group. Okay, and the chlorine is carbon number 2 and nothing is carbon number 3. Why? Okay, this is because the combination of the substituent for this numbering will be 1, 1, 2. Okay, 1, 1, 2. Compared if you label the chlorine as the carbon that attached to the chlorine as number 1, metal as carbon number 2, and nothing as carbon number 3. The combination of the substituent will be 1, 2, 2. Okay, you need to choose the smallest combination, which is the 1, 1, 2 compared to 1, 2, 2. Okay, so the number for this compound, the name of this compound will be 2-chloro. Okay, 2-chloro, 1,1-dimethyl. Okay, dan sambunglah belakang dia tu cyclopropane. Alright. Okay, next. Okay, dah habis. Okay, so for the question number 2, write the reaction mechanism. Okay, this is LO number 9 lah. Okay, when propane undergoes monochlorination in the presence of light. Actually kat sini I tersilap. This is not propane. Okay, as I told you earlier, propane is your exercise in the tutorial. Okay, so that we will discuss in the tutorial class with your respective tutor. Okay, so in this lecture, actually, we want to discuss about the mechanism of the ethane. Alright, the mechanism of the ethane. So before we go through the mechanism, the first thing first, I want to tell you that the halogenation process for the alkane, it will undergo in the presence of light. Okay, so indicates by UV, or in the presence of heat. Okay, we can put the triangle. Okay, if you do the reaction in the dark without any heat, okay, so there are nothing changes to the reaction, meaning that no reaction occurs. Okay, that is the first thing I want to stress out to you. The second thing, don't be confused between the type of reaction and also the name of the reaction. Alright, the type of the reaction is actually free radical substitution. Alright, why free radical? Because in the mechanism later on, okay, we will discuss later on, in the mechanism the free radical will form. Okay, and why does the type of the reaction is the substitution? Because we substitute the hydrogen with the halogen. Okay, and the name of this reaction is halogenation. Generally, we call it as the halogenation. Okay, and if we use the chlorine, for example, in this question, we use the chlorine, so the name is chlorination. If we use the bromine, the name will be bromination. Alright, and since we just want to replace only one of the hydrogen with the halogen, so we need to put mono in front. So monochlorination. Mono means one. Okay, monobromination. Okay, so let's discuss about the mechanism. There are 3 steps for the mechanism of the free radical substitution. Step number 1 is the homolytic cleavage of the halogen. Okay, homolytic cleavage. Okay, means you have the chlorine molecule. Okay, so in the presence of light or heat. So in this question, it is in the presence of light. So you write UV. The sigma bond between Cl and Cl will break, okay, and the electron, okay, will equally share between these 2 atoms. So one of the electron gives to the chlorine on the right and another electron gives to chlorine on the left. Okay, that's why we call it as the homolytic. Okay, sama adil. Alright. And the homolytic cleavage indicates by half-heat curve arrow like this. Okay, if heterolytic, for example, HCl, okay, we use the normal curve arrow like this, meaning that this is the transfer of 2 electrons. Okay, so in this case, hydrogen do not get any electron from the bonding, so hydrogen will lack of the electron, so it will be H+. Okay, tak cukup elektron. Elektron tu bercharge negatif, isn't it? Alright, so kalau tak cukup elektron, so dia akan jadi plus. Manakala chlorine get both of the electron from the bond, so dia terlebih-lebih dia punya elektron, maka dia akan jadi Cl-. Okay, terlebih elektron, maka dia jadi charge negatif. Okay, cation and anion. Okay, but when they equally share the bonding electron, okay, one give to the element on the left, another one give to the element on the right. Therefore, they will form the free radical. Okay, so it will form this species. Ataupun you can simply write 2Cl dot, boleh juga. Okay, tak perlu pun nak tulis Cl dot macam ni. Alright. So, what this Cl dot ni buat, or the free radical of the chlorine ni buat, okay, it will attack the ethane molecule. Okay, so we go for the next step, which is the first propagation step. Okay, so we have the ethane molecule CH3, okay, so this is the ethane molecule, react with the Cl radical. So the bond between C and H will break. One of the electron give to the C, okay, but another one electron will form the bond with the Cl. Alright, so we can see that these 2 half-heat arrow meet to each other, meaning that the formation of the sigma bond. Okay, so it will produce CH3, CH2, okay, and formation of the sigma bond between H and Cl, so jadi HCl. Okay, and remember this, we have 1 electron transfer to the C right now, just now. Alright, so the C will be the C dot, okay, the free radical of the ethane molecule. Okay, and this free radical will attack another chlorine molecule in the second propagation step. Okay, so this is still the second step, considered as the second step, continue from the previous. Okay, this is called as the second propagation step. So the radical of the ethane will attack the chlorine molecule. Mana datangnya chlorine tadi dah pecah dalam step nombor 1. Okay, you need to know that in the reaction, bukan hanya ada satu molekul sahaja. Okay, we have too much of molecule. So some of the molecule dah break in the first step, but there are still more chlorine molecule yang masih get intact. Okay, masih bersatu sebagai Cl2. Alright. So this ethane radical akan attack this chlorine molecule yang masih belum pecah ni. Okay, to form the bond between C and Cl, menyebabkan this bond break and one of the electron give to another Cl. So you will form CH dot plus, okay, I'm sorry, sini Cl plus Cl dot. Alright. So, in this step actually, we have produced the haloalkane, which is the 1-chloroethane. Okay, but this step will go to the previous step. I mean, we produce the Cl dot, and this Cl dot will attack the ethane molecule, the normal ethane molecule, to produce the ethane radical, and then the ethane radical will come here to attack the chlorine molecule and produce the chlorine radical. Okay, the silih berganti macam tu. That's why the name is the propagation. They propagate to each other. Okay, dia sentiasa bersilih ganti. Step number second propagation step. Okay, hasilkan the free radical that will be used in the first propagation step balik. Okay, and then the first propagation step hasilkan the free radical that will be used in this second propagation step. So this is some sort of the chain reaction, tindak balas berantai. Okay, dia sentiasa terus menerus. Okay, tak henti-hentilah. Okay, so how to end this reaction actually? So we need the termination step. Okay, which is the last step. So the termination step is actually when two free radicals meet to each other. Okay, for example, alright, we have chlorine radical and chlorine radical meet to each other. Okay, form the sigma bond. So form the chlorine molecule. Dia bentuk balik chlorine molecule. Okay, yang dah pecah tadi, dia jumpa sama-sama radical, dia bentuk balik chlorine molecule. Okay, so dia dah terminate, dah tamat kat situ. Unless kalau dia jumpa radical balik, barulah tindak balas perantai itu berlaku lagi. Ataupun dia jumpa dengan UV tadi, dia pecah balik. Alright. Selain daripada tu, we have ethane radical CH3, CH2 dot and CH2, CH3 dot. Okay, so this guy meet to each other, alright, to form a longer carbon chain, which is the butane CH3, CH2, CH2, CH3. Okay, but the most important, okay, we want to form the haloalkane. So that you need to write the equation of ethane radical CH3, CH2 dot meet with the Cl dot. Okay, so these two guys meeting each other from the sigma bond to produce the haloalkane product. CH3, CH2, Cl, okay, 1-chloroethane. Okay, 1-chloroethane. So, as you can see here, the 1-chloroethane is formed in two steps. Okay, in the propagation step as well as in the termination step. Okay, and that's why it is the main product lah. Okay, main product that we discuss. Okay, Yang lain ni kita tak discuss tadi. Yang ni kita tak discuss pun dalam soalan nombor 1 tadi. Yang ni pun kita tak discuss pun. Okay. Actually, selain pada chlorine molecule, butane molecule, 1-chloroethane, there are another product. Kalau you perasan, HCl yang terbentuk tadi. Okay. Because the overall equation, okay, the overall equation is actually CH3, CH2, CH3, CH3, Cl2, UV, okay, produce CH3, CH2, Cl plus HCl. Okay, so this is the important byproduct, tapi kita abaikan sahaja because we want to focus for the haloalkane product, which is the organic compound. Alright, so with this discussion, I hope you understand in order to answer the question in the tutorial exercise. Okay, but you need to bear in mind that when we do the exercise for the question number 1 just now, okay, the propane will produce two possible haloalkane product, which is one chloropropane and also 2-chloropropane. Therefore, okay, in the propagation step, in the first propagation step, there are 2 equations. In the second propagation step, there are also 2 equations. In the termination step, it is much more equation than this. Okay, this one we have 3 equations. Alright, this one we only have 1 equation, 2 equation, 3 equation. Alright, and this equation is the most important lah. Okay, equation number 3 tu is the most. Okay, yang purple ni, ini is the general equation, persamaan keseluruhan. Alright, but as for the propane, the termination step can be very, okay, banyak sangat, pelbagai dia punya termination step. So you can try by yourself what are the possible answer for the what are the possible equation for termination step of the halogenation of the propane. Alright, so I think that all, okay, for this lecture, and I hope for the lecture number 4 we can meet face to face again, but I just only will teach for the physical one. Okay, for the physical 2 you will meet your Puan Zuraini. Okay, Hayat 1 is Puan Mahfuza and Hayat 2 is Dr. Daniel. Okay, until we meet again. Okay, wassalamualaikum warahmatullahi wabarakatuh dan selamat belajar.